Good morning, children. So welcome back to the online session of a physics class. So as we know that we are discussing about the lesson live, that we are I'm giving the answers for the exercise questions. So in that I have given up to 14th question I have given the answers. So we will discuss about 15th question in today's session. Okay. So even 14th question is also a numerical problem that I had given the data. What is the focal length in the radius of curvature is given, which is 30 centimeter. So we have to convert it into a focal length f. So how to find out f is nothing but radius of curvature divided by 2. Half of the radius curvature will become the focal length. We know that whether it may be a convex mirror or a concave mirror, even okay, so let me take a concave mirror. So in that I am having a focal length f, and then I am having a center here. So the distance between center to the mirror will become the radius of curvature, right? So focal length will be exactly half of that. Focal length will be exactly half of the radius of curvature, or radius of curvature is nothing but 2 times of f. This we know that we have learned in relationship between the radius of curvature and focal length, right? So there we have learned that radius of curvature is equal to 2 times of focal length, or focal length is equal to r by 2. Very easy. If you take 2 to the other side, it will get divided. So f is equal to r by 2, or r is equal to 2f. Okay. So using that, we will be going to find out the focal length. That is I'm talking about the last question, 14th question, not 15th question. Okay. So in that we have to find out the focal length, object distance they are given, then object length they will be given. Using those data, we need to find out the position, size, then nature of the image work time, right? So for that we need to use they have given that concave mirror or convex mirror. So 14th question will be talking about convex mirror. So according to the mirror, we should take the sign. Object distance is always negative. Object distance is always negative, right? Because object we will be keeping in front of the mirror. So that is we are keeping on the negative x-axis. Okay. So object height will be positive, right? We will be taking a erect object only. We are not taking the inverted object. We will be taking a erect object only. So object height is also positive. So whenever in the question they have mentioned that we should take the inverted object, then we should take object distance as object height as negative. But here it is a erected object only, so therefore it is a positive. It will be on the positive axis on the right. Okay. Then we need to find out using the mirror formula. We should find out the V, that is image distance. Image distance by observing the sign of the image, that is image distance. By observing the sign of V, we can able to find out that image will be formed on the positive axis or negative. Positive x-axis or negative x-axis. If it is value will be positive, then it will be formed behind the mirror, or otherwise in front of the mirror only. If it is V will be negative, then it will be in front of the mirror only. So by observing that sign of the V, we can able to obtain the position of the image of time. Then, so whether it is a nature, whether it is a virtual image or real image. In order to get virtual image or real image, we need to find out the magnification. So what is magnification? Magnification is equal to minus image distance divided by object distance. Substitute that, look at that whether you are getting a positive sign or negative sign. If you are getting a positive sign, then definitely it is a virtual image. If you are getting a negative sign, then definitely it is a real image. Okay. So in order to get whether it is a what will be the size, whether it is a smaller or bigger. So use the same concept of magnification. Height of the object, height of the image divided by height of the object. Find out the height of the image. So if you find out height of the image, you know the height of the object. Compare the height, whether the image height will be smaller or greater. By observing the value, we can able to find out that. Okay. So that is about 14th question. I have given the homework to you. So now we'll discuss about the 15th question. Okay. The 15th question is, an object of size 7 cm in length is placed at 27 cm in front of a concave mirror. Here it is a concave mirror. Here is a concave mirror. concave mirror. Okay. Okay. It is placed. The object size will be 7 centimeter. Object size will be 7 centimeter. Let me take ABS object. It is having a size 7 centimeter. It is kept at 27 centimeter from the pole. 27 centimeter. Okay. In front of a concave mirror, correct? A focal length 18 centimeter. Focal length 18 centimeter. Let me take this as a principal focus here. Then focal length will be how much? 18 centimeter. Okay. Right? Then at what distance from the mirror should a screen be placed so that a sharp focused image can be obtained? So, at what distance I need to place the screen in order to obtain the image? That means where is the image is formed? What is the position of the image? So, find the size and nature of the image obtained. That means again we need to find out the position, size and nature. Here they have given that at what distance from the mirror should the screen be placed? At what distance should the screen be placed? What is the position of the image? Right? So we need to find out what is the position of the image. That means we need to find out the image distance. Image distance. So let us list out what is given. So object height will be given. Object height. Object height h is equal to 7 centimeter. Object distance. Object distance. What is object distance? Object distance is u. It will be denoted by u. Object distance u is 27 centimeter. 27 centimeter. Okay. Focal length. Focal length. F is equal to 18 centimeter. So after writing the value, we should come to the sign of these values. Okay. Object height. Object height. So it is on the positive x-axis, positive y-axis. So it is positive. Okay. Object distance 27 centimeter. Object distance. Object will be placed in front of the mirror. So it is on the negative x-axis. So it is minus. Focal length. Focal length will be on the negative x-axis only. Since it is a concave mirror, so it is focal length is also negative. Observe that it will be there in the negative x-axis. Okay. So this is also negative and this is also negative. So what we need to find out? We should find out image distance in order to find out at which place we need to place the screen in order to obtain a sharp image, sharp focused image. So let me find out that using mirror formula. Using mirror formula. What is mirror formula? 1 by v plus 1 by u is equal to 1 by f. Okay. So we need to find out 1 by u. Keep 1 by u here on this, send 1 by u to the other side. What will happen? So 1 by v on LHS only. In the RHS I am having 1 by f. If I send plus 1 by u to the other side, it will become minus 1 by u. Correct? Okay. Now let us substitute the values. 1 by f, focal length. Focal length is minus 18 centimeter. Minus 1 by u. U is minus 27 centimeter. Okay. So we will be having the negative sign in both the values. We should be very careful. Let me transfer this negative sign to the numerator. Okay. So what will happen? When I transform negative sign to the numerator, minus 1 by 80 for the first term. For the second term, I am having a negative operation. We will write as it is, and we will transfer this negative operation to the numerator. Okay. Then minus 1 by 27. Here. So this is the negative operation. This minus will be transferred to the numerator. Okay. So we'll bring into the we'll multiply these two and we will simplify this. Okay. So 1 by v on the LHS as it is. RHS. So it is minus 1 by 18. So minus into minus will become plus 1 by 27. 1 by 27. Okay. So what we will do, we will simplify this. We will simplify this. We will cross multiply this 1 by v. Okay. 1 by v. We will cross multiply this minus 27 plus 18 into 1 will become 18. 27 into minus 1 minus 27. 18 into 1 is 18 divided by, so we need to multiply these two. 27 into 18. So 8 sevens are 56. 8 twos are 16. 16 plus 5 will become 21. 1 sevens are 7. 1 twos are 2. So 6, 8, 4. 486 divided by 486. 486. Okay. Now, so 8 sevens are 56. 5, 8 twos are 16. 16 plus 5 will become 21. 1 sevens are 7. 1 twos are 2. So 6, 8, 4. 486. So 1 by b is equal to minus 27 plus 18. We need to subtract it. If you subtract 18 from 27, it will become 9, right? So 9 between these two, 27 is higher before the having negative sign. So 9 by 489, 486. 486. Okay. Next. Again, we will take the reciprocal of LHS. Then it will become d by 1. Here also we will take the reciprocal of this. Then we will keep the sign a on day. So 486 divided by 9. If you are taking minus 9 to the denominator, again we need to set the sign to the numerator. Let me keep the sign over there only. We will interchange the numbers only. 486 in the numerator, 9 in the denominator. Because LHS I have take the reciprocal, right? So 486 divided by 9. We will divide it and we will get the answer for this. 486 divided by 9. So how many times it go? So 9 ones are, 9 twos are, 9 threes are. So 9 fives it go, 9 fives are 45, right? So 3 will be remaining 6. So 9. So it is not going to divide, it will be coming at point, right? So what is the value of B will be getting 8 point something. So we are getting B is equal to, so B is equal to minus 54. So it will be divided by 9 fours are, right? 9 fours are 26. So 0. So what is the answer? 54, right? So we will write that. So b by 1 is b only. So I am having a negative sign. If you divide 486 by 9, you will be getting a 54 centimeter. So you can observe that b is equal to minus 54 centimeter. So b is equal to minus 54 centimeter. Then we should write the conclusion. Okay. Observe that you will be getting a negative sign in the image distance. That means image will be obtained this side. Then only, image is obtained here only. Okay. So if you are getting the image here in the sense, you should get positive sign. Here you are getting a negative sign only. Therefore, image is obtained on the negative x-axis only. Negative x-axis only. Right. So we will conclude that. So it is the screen should be placed at a distance of. The screen should be placed. The screen should be placed at a distance of 54 centimeter in front of the mirror. Okay, in front of the mirror only. Why in front of the mirror? Because I am getting a negative sign. So image will be obtained on negative direction only. I mean a negative x-axis only, at the same side of the mirror only. If it is positive, then image is obtained on the other side of the lens, behind the lens. Behind the mirror. Okay, since I am getting a negative sign, so distance will be on the negative x-axis only. Therefore, image will be obtained on negative x-axis only. So therefore, in front of the mirror only. The screen should be placed at a distance of 54 cm in front of the mirror. Okay. So that is the first question. Where should we keep the distance? Where should the screen should be placed in order to get a sharp focused image? Now, second question: find the size and nature of the image obtained. Find the size and nature of the image obtained. In order to find nature and the size, especially to find out the nature, whether it is a virtual or real, we should find out the magnification. We should find out the magnification. So let me find out the magnification. Then using the magnification, we will find out the height of the image. So then object height will be there, image height will be there. We will compare that. So which is more? So image height will be more in the sense enlarged image. Image height will be less in the sense it is a smaller image. We will conclude that. Okay. So we'll write m is equal to magnification m is equal to minus image distance divided by object distance. Image distance divided by object distance. B divided by u minus v divided by u. M is equal to minus image distance is, what is the image distance we got? Minus 54, right? So we have it minus in the formula itself. So image distance is minus 54 centimeter. Minus 54 centimeter. So object distance. Object distance minus 27. Okay. So what you will be getting? So numerator minus will become plus 54. Denominator minus 27. So 27 ones are 27, twos are 54. So we will transfer the negative sign to the numerator. Minus 2 by 1 is 2 only. So magnification you are getting minus 2. Magnification you are getting minus 2. Very important, you are getting a what sign? Negative sign. So the negative sign of the magnification indicates that image will be obtained is real or virtual. If you are getting a negative sign, then definitely it is a real image. So definitely it is a real image. If you are getting a negative sign, then definitely it is a real image. So that you can conclude that. So if it is a real image, then it is inverted. If it is real image, then it is inverted. We will conclude that the negative sign of the magnification indicates that the negative sign in the magnification indicates that image is real. Image is real. If it is real, then definitely it is inverted image only, right? So whether it is inverted, okay, real and inverted. Okay. So using again the same magnification, we'll find out the image I. We'll continue that. Okay. After that, again should continue. Okay. So we have find out the magnification. We are getting magnification minus 2. Right there. So we are equal to minus 2. Okay. Now we have one more formula for the magnification, that is image I positive. Image I h dash divided by object I h. Correct? Magnification is equal to image I divided by object I. We have two formula for the magnification, right? Even in mirror also, even in lens also. In terms of I, both for mirror and lens it is same. Magnification is equal to image I divided by object I, whether it is a mirror or it is a lens. Okay. Distance, in terms of distance, magnification formula for the mirror, image distance divided by object distance minus for the mirror, whereas for the lens, positive. Image distance divided by object distance. That is the only difference for the magnification, right? But in terms of height, same for mirror also, then lens also. Okay. So we are getting magnification minus 2. We'll substitute that. Image height, we don't know, we should find out. Let me correct as much as keep as it is. Object height is 7 cm. Object height is So we cross multiply that. I think in a sense it is 1, right? So 7 into minus 2, minus 14. 1 into h dash, h dash. So h dash is equal to minus 14 or h is equal to minus 14 centimeter. I'm sorry, h dash is equal to minus 14 centimeter. What is h dash? H dash is image height. Image height. You can observe they are getting negative sign. That means image will be in the negative x direction. It is a negative y direction. Negative y direction. Okay, so it is a negative y direction. It is like this. So it is obtained at 54 centimeter. So it is 27, right? So image will be obtained somewhere else like this. It's around 14 centimeter. It is double the object. 15 centimeter. This is A dash, B dash. So this distance from zero is 54 centimeter. Okay. So this is the image work time. Image work time. We will conclude this one also. That is negative sign of I indicates that. So there the sign is not required. You can observe that object height is 7 centimeter. Image height is 14 centimeter. So which is whether the image is enlarged or smaller. This is 7 centimeter. Object height will be 7 centimeter. Image height will be 14 centimeter. H dash is 14 centimeter. So obviously it is an enlarged image, right? So we can conclude that. So therefore, image of time. Image of time is time what is that? What we have done? On the image of time in front of the lamp, in front of the mirror, that is position in front of the mirror, virtual image, real and corrected, real and inverted, enlarged image. Okay, these are the properties. That means size, nature of the image of time, then position of the image of time. Position in front of the mirror, it is a nature will be real and inverted, size will be enlarged image. Okay, so this is about 15th question. So we'll go for the next question, 16th question. Okay, 16th question, it is it's very easy. So the next question, 16th question is, find the focal length of a lens of a power minus 2.0 diameter. What type of lens is this? You should find out the focal length. We have already done that in questions, power of a lens concept. So here they have given the power. We should find out the focal length. What is the relationship between power and focal length? We know that power of a lens is nothing but power of a lens P is equal to 1 by focal length in meters, right? So this is the power of a lens will be denoted by diopter. So power of a lens is nothing but 1 over f focal length. Here power of a lens is given. Power of a lens is nothing but P is equal to how much? Minus 2.0 diopter. Minus 2 diopter. So we'll substitute in the power of a lens formula. We know that P is equal to 1 by f, or if I cross multiply that, or otherwise if I say P to here and f to here, then f is equal to 1 by P, or f is equal to 1 by P. P is equal to 1 by f, or f is equal to 1 by P. If I cross multiply P to here, then f to here. If I send transform f to LHS, it will get multiplied. If you send P to other side, it will get divided. That's it. Okay. Then focal length is equal to 1 by power is minus 2. Okay. So f is equal to this minus will be transformed to the numerator. If we divide 1 by 2, it is 0.5 meter. This is focal length. F is equal to minus 0.5 meter, which is the focal length. And the next question is, what type of lens is this? What type of lens is this? By observing the sign of focal length, I can say that whether it is a converging lens or a diverging lens, whether it is a convex lens or a concave lens, right? So you know the focal length is negative, so it is a convex or concave. Focal length will be negative for concave, so it is a concave lens. In fact, it is a diverging lens. So therefore, since f is negative, since f is negative, it is a concave lens. Concave lens, in fact, it is a diverging lens. Diverging. So concave lens is a diverging lens. Convex lens is a converging lens in terms of lens. Okay. So focal length of sign will be same for mirror also, for lens also. It is negative for the concave and positive for the convex. So convex is a positive, concave it is negative focal length. So if you are getting focal length negative, so it is a concave lens. Okay. So here we have given the power of lens. So use the formula, power of lens is nothing but 1 over focal length, or focal length is equal to 1 over power of lens. Substitute the power value that given in the question. So 1 by 2, if you divide 1 by 2, so you will be getting 1 divided by 2. So nothing reasons. You will put a 0, then 1, put the point, 0 to 5 are 10. So 0.5 I am getting 0.5. Sign will be as it is. Focal length will be measured in meter. So therefore focal length is negative here. It is a concave lens. If it is a positive, then it is a convex lens, converging lens. Right? So we have one more question, 17th question. That will be the homework for you. The same type of question it is. There also they have given the power of a lens, that is plus 1.5 diopter. Find out the focal length. After finding out the same focal length, then after finding out the focal length, what type of lens it is, a diverging lens or converging lens, convex lens or concave lens. So that is the homework for you, 17th question. Do it. So this will complete the lesson. So I have completed the lesson and I have given the answers for all the questions. Some of the questions, in between 1 or 2 questions, I have given the homework to you. So complete that. If you have any doubts in that question, please get back to me. So we will discuss about that question. Okay. So I will be conducting a test for live lesson in the next week. So Tuesday I will be conducting a test for mathematics circles. So I will be conducting a test on Friday for the live lesson. The entire lesson I will be conducting a test. So prepare for the lesson. Okay, both numericals as well as the concepts whatever I have taught in the live lesson. Start from the beginning. Okay. So thank you. That's it for today's class. In the next session we will go for the next lesson. Okay, that is magnetic effect of electric current. Okay. So thank you. We will meet in the next video.